Hi, my name is Stephen McGee and I'm the author of Toxic Electricity. Now, we're here today to look into the Earth's natural magnetic field. And what we're looking at is a plate, and this is just a standard paper plate, and it has a magnet on the back of it. So this magnet is behind that circle that you can see that's drawn on it. And that's going to simulate our magnetic field of the Earth. And the reason why we're doing this experiment is because it's been noted in recent decades that the poles are actually accelerating out of their positions. They've been slowly on the move for a few hundred years now, and this last century they've accelerated. And I was starting to wonder why that would happen. So this experiment is designed to show you one of the reasons. Now, there's a number of reasons why the Earth's pole may accelerate out of its position, and one of them is the widespread adoption of AC electricity around the world. Those systems have very large losses in them and create very large magnetic fields. So when you start generating massive amounts of electricity, you shouldn't be too surprised if you affect the Earth's natural magnetic field. And the other thing that may affect the Earth's natural magnetic field is the large-scale removal of trees. And most scientists know that there's a very large flow of ions passing through the trees from the ground into the atmosphere. And as such, there's very large energy flows associated with trees. And if you remove massive amounts of trees from the surface of the Earth, then you're going to affect those energy flows, which will in turn affect the Earth's magnetic field. So this is a third effect that I've identified. And the reason why these three nuts are here is simply because if you concentrate metal, as humans do, into cities through mining activities, basically humans are mining in massive amounts all over the Earth, and then they're processing those materials that they mine, and then they're bringing them into the cities in the form of cars, metal buildings, and just general metal in everything, such as mattresses and things that you buy. Anything that has metal in it has come out of the ground somewhere in the world that was once a mine. So we have these three nuts, and they're going to simulate what humans have done, and that is they've concentrated metal into cities. So these are going to simulate three cities. So that said, let's start the experiment. So we have some iron filings, and we're going to start sprinkling them and see what happens. So we can clearly see the fields coming out from the north and south. They basically come out straight, and then they wrap around into the center of the Earth. But one of the things you'll notice is that where the nuts are, we have high concentrations of iron filings, and that indicates that the nuts are actually magnetic, so they're attracting the iron filings. And we can verify that simply by moving them. So if we move them around, we can see that the iron filings are following them. And this one as well. So we move one all the way out to the edge, we see that the field's not strong enough to make the filings follow them anymore. But as soon as we get a little bit closer to the center, they become magnetized, and the iron filings start sticking to them. So the conclusion I've come to is that if you do concentrate massive amounts of metals out of the Earth's core into cities, then those cities actually start to interact with the Earth's natural magnetic field. And the bigger you build those cities, the more of an effect that it will have on the Earth's natural magnetic field. And you're not going to see that effect immediately. There's always going to be some kind of lag to pull off the Earth's natural magnetic field, and I believe that's what we're seeing right now. I believe this acceleration of the Earth's natural magnetic field is actually caused by large-scale concentrations of metals in cities, as well as the other two reasons that we previously discussed. So that was the purpose of this demonstration. I hope you enjoyed it, and I wish you the very best of health. Thank you.